concept of probability, the idea of probability. You have, in every single chance of probability, there's an experiment that is happening. That is what probability is. It's an experiment that involves chance. Okay, it's the idea of chance events happening. So when you perform an experiment like what we did earlier, rolling a die or flipping a coin, these are all activities that involve chance events. Okay, so experiment is a big thing to understand. A trial, when we talk about trials, we're talking about how often you are performing an experiment. How often do you flip the coin? How often did you roll the die? How often did you spin a spinner? Okay, an outcome. The outcome is the result of your experiment. When I wanted to land on tails, that's the outcome that I'm trying to achieve. However, there are more than one outcomes for flipping a coin. There happen to be two outcomes. Okay, so the result of an experiment, what does it land on? Those are all the possibilities that it could potentially be. Then the event, that's the set of outcomes that you're trying to achieve. So when I'm trying to land on tails, that's the event that I'm looking for. When I was trying to land on a 5 or a 6, that's the event that I'm looking for. And then we have our probability number line. And I know that this is a little bit difficult to read towards the bottom. It didn't print it out very nicely. But for here, it's showing you the different ways to be able to display probability. So you can display probability as a value of a fraction. So 0, 1/4, 1/2, 3/4, or 1 whole. You can display it as a decimal. So those are the forms in decimal format. You can display it as a percentage. So here's our percentage format. So probability, this is a very big thing for you to understand. Probability is out of 1 whole. Write that down. Probability is a value between 0 and 1, or 0% and 100%. It is a value that ranges between 0 and 1, or otherwise known as 0% to 100%. Now, when we are looking at probability here, we have specific terms of likelihood, how likely an event is to occur, how likely a specific event is to occur. So if a probability is 0 or 0%, what do you think that that's called, Alex? Okay, absolute 0. Okay, does it have any possibility of happening? No, it's impossible. So this is an event that we call impossible. So right above the 0, I want you to write impossible. Directly at 0, that's the value of impossible. It has no chance of occurring whatsoever. 0% probability. It is an impossible likelihood. Okay, then smack dab in the center, right here at 1/2 or at 0.5 or at 50%, those are equal chances. It has an equal chance of happening as it does of not happening. So what we call this is equally likely, or as likely as not. That means that you have the same chance to happen as you do to not happen. Okay, when people go and do those gender reveal parties, you got 2 outcomes there. Okay, when they're doing a gender reveal, okay, it's either going to come out pink or it's going to come out blue. That's a 50-50 chance. When you flip a coin, that's a 50-50 chance. Okay, Then all the way at the very, very end, at 1 whole, at 100%, we call those events certain. They are guaranteed to happen. It has a certain probability. Now, everything in between those events have terms of unlikely to likely behavior. So from the impossible, ranging all the way up to the equally likely, this creates a category, a large category of unlikely probability. It can happen, but it's unlikely. Okay? So this is a very large range. 1% is unlikely. 49% is unlikely. 49.9 repeated percent is still unlikely because it's less than that 50%, but it's more than 0. Okay, so this has a very large range of unlikely values. It just might be that 1% is considered to be significantly unlikely compared to 49%, which is only slightly unlikely. And then what do you think we call it? Anything that's above 50 but not 100. What do you think we call that? Likely. Anything above 50 but not quite at 100, we call that likely. Okay, so that's our likelihood. Now, probability is written as P of whatever event that you're looking for. And when we write it, we find the possibility, okay, the number of times that the event will happen out of a total number of possibilities. So for example, when we did the die, we know that the total number of possibilities is 6, but we wanted a 5 or a 6. So there's 2 ways that we could land on the specific event. So that would be 2 out of 6, or 1/3, which is considered to be unlikely. Okay, so what I want you guys to do right now, I have 4 scenarios here. I want you to find the physical probability, the fraction value of the probability, and then based off the fraction value of the probability, you're going to identify its likelihood. Is it impossible, unlikely, equally likely, likely, or certain? We're going to do the first one together, only because a lot of people get tripped up by this. Picking a month with 28 days in it. How many months have 28 days in it? All of them. Some people say 1, but that's 1 month that has exactly 28 days. But every month has a 28th day in it. So there are 12 months, right? So that means that there are 12 months that have 28 days in it out of a total of 12 months. What does 12 out of 12 come out to? 1 whole. So the probability here is 1 whole, or 100%. What does that make it? What likelihood? Certain. So I want you guys to go ahead and take a moment and do problems 2, 3, and 4 on your own. Okay, let's go ahead and go over this. So the probability of rolling a number that is greater than or equal to 3. That means that we are looking at the numbers 3, 4, 5, or 6. That is a total of 4 numbers out of 6 possible values, right? We have a 1, 2, 3, 4, 5, or 6 on the number cube. That's 6 numbers that are our total possibilities. 4 out of 6, though, that can be simplified. What can we simplify 4 out of 6 to? To 2/3, right? They're both divisible by 2. That would simplify to 2/3. So 2/3, what kind of probability is that? Likely. Thank you, Elijah. So this is a likely probability, right? It's greater than 50%. So this is considered to be likely. Flipping a coin and landing on tails. So we've done this before, right? We did this today in our little warm-up activity. We want to land on tails, but we have the probability or possibility of landing on both heads and tails. Those are our two possible outcomes. So there's only one tails on the coin out of two possible outcomes. So our probability is 1 out of 2. What event is that? Equally likely. That's an equally likely possibility, okay? And then a spinner. We're going to spin a spinner and land on 15. Spinning, oh, and I should have probably showed you the same spinner that we had last time. If we were to spin that spinner, I'm so sorry I didn't show you that before. Maybe we'll draw it down there too. If we have a 5-section spinner labeled 1 through 5 and I want to land on a 15, can I? No, that's a 0 probability, right? So there are 0 ways to land on it out of 5 numbers that happen to be on that spinner. 0 out of 5 is going to come out to an impossible event, right? 0, which is impossible. Any questions so far? All right, let's go ahead and move on to the next page. So a complement. Complements and probability, those are the set of outcomes that are not the event. So if I'm saying, hey, the probability of landing on an even number is going to be 1/2, then the complement would be to not land on an even number. So we call it the not probability. So here we have a bag of marbles that contains 6 red, 6 blue, 3 green, and 1 yellow. The probability that we're going to land on red is 3 out of 8 because there happens to be 6 reds out of a total of, 16 total marbles. 6 out of 16 simplifies to 3 out of 8. I want the probability that it's not going to be red. Not going to be red. So for it to not be red, that means it could be blue, it could be green, or it could be yellow. And I don't have a yellow, so I'm just going to write it in orange. It can land on a blue, it can land on a green, or it can land on a yellow out of the total. So we happen to have 6 blue, we happen to have 3 green, we happen to have 1 yellow. We're just going to add those together. 6 plus 3 plus 1 is going to come out to 10. So we get 10 out of 16, which is going to simplify down to what? 5 out of 8. So the probability of it not landing on red would be 5 out of 8. Okay, if we roll a die and the probability of landing on a 5 or a 6 was 1/3, we want the probability of not landing on a 5 or a 6. So that means we can land on a 1, a 2, a 3, or a 4 out of all 6 total numbers. That's 4 options. That's 4 options out of the 6. And what does 4 out of 6 simplify to? 2/3. And then picking a queen. Picking a queen out of a deck of cards is 1 out of 13. We want the probability that you're not going to pick a queen. How many queens are there in a deck of cards, guys? 4. And there's 52 cards in the deck. So if there are 4 queens, that means all the rest of the cards are not queens. That means there are 48 cards. There are 48 cards that are not a queen out of the total 52 cards. That's going to simplify down to 12 out of 13. Now, do you notice a trend here? The probability of an event happening and the probability of it not happening should be a combined probability of 1 whole. 3/8 that it will land on red, 5/8 that it will not land on red. If you combine 3/8 and 5/8, you get 8/8, which is 1 whole. So the probability is either going to happen or it's not going to happen, right? 1/3 plus 2/3 is 1 whole. 1/13 plus 12/13 comes out to 1 whole. You either happen or you don't. There is no in between. You land on tails or you don't land on tails. So the probability and its complement, when you combine those together, will always come out to 1 whole. Any questions? All right. Real quickly, some word problems. I want you to go ahead and answer these two based off of the problems that they're based off of the situation that they're presenting. If Eric's teacher almost always gives a quiz the day after a lesson that students didn't ask many questions, should he expect a quiz on Monday if nobody asked questions during Friday's lesson? Okay, his teacher almost always gives a quiz the day after nobody asks questions. So if no one asks questions on Friday, should he expect a quiz on the Monday after, the next Monday? And then second question, Todd rarely watches TV for longer than 30 minutes in the afternoon. If he started watching TV at 4 p.m., how likely is it that he's going to still be watching by 5 p.m.? Okay, Eric's teacher almost always gives a quiz the day after the lesson that students didn't ask many questions. Should he expect a quiz on Monday if nobody asked questions on Friday? Yes or no? Yes, right? It's likely. The fact that it says almost always means that it's likely. It doesn't mean that it's certain, but it does mean that it is a likely probability. So yes, he should go ahead and expect to have a quiz that day. What about Todd? Rarely watches TV for longer than 30 minutes in the afternoon. He starts at 4 p.m. How likely is it that he'll be watching at 5 p.m.? Unlikely, right? That term rarely is an unlikely term. So that would be an unlikely situation there. Okay, loaded into Google Classroom is your assignments for today. You have 2 IXL skills. Remember, in IXL, your SMART score is a 70. Once you get to a SMART score of 70, you can move on to the next skill. After you're done with that, you should then progress to Prodigy Game. There are 16 questions that are an assignment. After the 16 questions, it's just a diagnostic. So you can play after 16 questions still, but the first 16 questions are going to be an assignment. You need to have this all completed before class tomorrow.